Okay, going back to our slide. So here's the solution. The solution to this problem is to add a copy constructor. All right. What this code is, let's just copy and paste so that we can move on to other things today after examining this. So the amendment to this problem is that, okay, if I want to kind of keep it nice, I can say, okay, these are our data variables, right? Then we have our constructors. And I typically also say, okay, destructor also goes into this section. So later on, I may add some operations, but most likely this particular thing is not going to have any. So this is called a constructor that takes particular argument. So it's specific constructor. So here is a copy constructor. First of all, the curious syntax here is that copy constructor, just like any other constructor, is named the same way the class is named, right? This is how it's recognized that this is actually a constructor. By looking at its name and say, oh, it's the same exact name as the class name. So that's why we say, okay, we know that it's a constructor. Then it says, in order to be recognized as copy constructor, let's use a reference to refer to another object. Consider this. If there were no references available in C++, then perhaps what could have been happening here is this, right? No references. We just say, look, we have this class named Terminator. We want to control how construction is taking place. We want to do something when copies are being made. That's the second part of this discussion. But first, we need another object to make a copy constructor. So basically, our parameter here has to have access to another object. So basically, in our illustration, when the Bob is constructed, it wants to have access to Alice, and its implementation of the copy constructor will basically do something intelligent to prevent that crash from happening. Okay, but think about it. We said that by C++ says, by its rule book, by its standard, says that when an argument is passed by value like this, a copy has been made. So this copy constructor, this version of the copy constructor becomes a runaway train, because in order to give Bob access to Alice, we need to make copy of Alice simply to be able to call copy constructor. That means that as soon as we attempt to make a copy, we're invoking the Terminator constructor, copy constructor, recursively, again and again and again and again. So this is really a very bad idea. It doesn't work. So therefore, we may be using pointer to refer to another object indirectly, but that would force us to use this ugly part saying, oh, we have to remember that we need to take a copy of Alice in order to be able to construct Bob. So we don't want that. We would, as I can right now, as I can say, integer x equals another integer y, I would like to be able to construct copies of my objects by using very simple syntax. So say, okay, Bob, take Alice as for initialization purposes and create yourself based on your copy constructor or default copy constructor. So for this, reference plays a very important role. So remember, if we use a reference here, then this semantics will be supported fully. We don't need to take address of Alice to be able to provide argument to this copy constructor. By the way, it's advised to use a standard semantics like initialization syntax, but I could use this as well, right? I could use explicitly, basically saying, okay, I'm constructing Bob and I'm taking Alice as a parameter, and therefore this copy constructor will be taking this parameter, and of course I'm using a reference. So this is our first view of the copy constructor, and this copy constructor takes indirect reference to another instance of the terminator, and it does it indirectly by using reference, and provides, by the way, this syntax is preferred. So let me go back to there's a slide that talks about it, but this syntax should be considered preferred syntax when you're copying objects. Just use standard initialization semantics when you make copies of your object. Okay, so what does this copy constructor do to remedy the problem? So by the way, let's save this and build it and run it and see if the problem goes away. So Control F5, just execute it. So yes, it seems to be going away. And the solution is this. This copy constructor says, well, I do realize that this becomes extremely dangerous to just say, all right, by design, we want to delete an existing integer that was allocated dynamically. There is a scenario apparently here which will crash the program or may lead to unpredictable behavior because you cannot delete the same pointer twice. Or you should not, by the rule. So what happens here, we say that, okay, let's design a copy constructor which will control how Bob is manufactured. And yet, it still has access to Alice through a reference to Alice when this copy constructor is invoked. We can directly